Now, we studied about how sounds are produced due to vibrations. But haven't you wondered how the sound travels from one point to another? For example, how the sound travels from you to your friend. So let us find out how sound travels from one point to another. Here you see that the molecules of the medium around the speaker are vibrating in a to and fro motion about their mean position while the disturbance is traveling outwards. So doesn't this all sound familiar? The sound that was traveling is a vibratory disturbance. The energy was being transferred from one point to another, and there was no direct contact between the speaker and where the sound was traveling. So vibratory disturbance, energy was transferred from one point to another, and no direct contact between the 2 points. So what does this signify? Yes, this signifies a wave. So sound we find is a wave. Now let's take a quick recapitulation of how many types of waves there were. There were transverse waves and there were longitudinal waves. What were transverse waves? Transverse waves were those types of waves where the vibration of the medium particles were in a direction perpendicular to the direction of motion. And what were longitudinal waves? Longitudinal waves were those kind of waves where the vibration of the medium particles was in a direction that was the same as the direction of propagation of the wave. Now let's take a look at another video. In this video, we find what happens when human beings speak out. Here we see that when air from lungs is making the vocal cord vibrate, the air is leaving in compressions and coming out of our mouth. These compressions of air travel in the forward direction. Now you must recall that this seems somewhat similar to the motion in a slinky. What used to happen in a slinky? When a slinky was compressed at one end and released, that compression traveled in the forward direction along the length of the slinky, as you're going to see in the video right now. Here you see that the compression travels along the length of the slinky from one end to the other end. Now let's take a look at the previous video one more time. What similarity do you find between the particles vibrating around the speaker and the motion of the slinky? Can you find any similarity? Look closely. Yes, you are right. These particles were also vibrating along the direction of the disturbance, just like the slinky, where the compression was traveling in the direction of the slinky. So, we can conclude that sound waves are longitudinal waves. Now let's take a look at what happens when sound travels through a medium. In this animation, you find that the medium particles are vibrating to and fro about their mean position. Now consider one medium particle that has been shown by the red arrow. If you closely observe it, you will find that that particle is vibrating back and forth in the direction in which the wave or the disturbance is traveling. Likewise, if you observe any other particle of the medium, you will again notice that they are also vibrating back and forth in the direction of the traveling wave. Thus, clearly, it is a longitudinal wave. Now, can you tell me why the blue circles are becoming dark ones and then again becoming lighter? Well, let me explain it to you. You will notice that when the medium particles are coming very close to one another. That is, they are becoming very dense. The blue circles, they are getting darker. This indicates a compression. A compression is when the medium particles are coming close to one another and forming a dense region. Now, the very next moment, they are again becoming light. What does this indicate? When the medium particles are going far apart from one another, the blue circles are becoming lighter. This indicates rarefaction. A rarefaction is when the medium particles are going far apart from one another and forming a region of low density. So, what did we learn so far? We learned that sound waves are longitudinal waves. Sound waves can travel through air in the form of compressions and rarefactions. A compression is when medium particles come close to one another and form dense regions, and a rarefaction is when the medium particles move far apart from one another and form a less dense region.